Transmission Technology Basics. 1. Serial transmission and parallel transmission. Serial transmission and parallel transmission are available for sending encoded data over communications line. Serial transmission transmits one bit at a time. Parallel transmission transmits multiple bits simultaneously. 2. Synchronization. In order to properly receive data that is sent, the position of each bit and the beginning location of the data have to be known by the receiving side. In order for the sending side and the receiving side to match up their timing, synchronization is performed. Synchronization is the operation that identifies the position of each bit and the beginning of the data. In synchronization, there are two types: bit synchronization where each bit is synchronized, and block synchronization, where multiple bits grouped in units of bit strings are synchronized. There are other systems of synchronization as well. A. Bit synchronization. Consecutive synchronization mode. Data and the synchronization signal are overlapped and sent. The synchronization signal is removed and the data extracted at the receiving side. Asynchronous mode. A start bit and one or two stop bits are attached before and after each character. When the receiving side detects the start bit, it knows that it is the start of the data. This is also known as the start-stop synchronization mode. B. Block synchronization. Start-stop synchronization mode. Refer to the asynchronous mode. Character synchronization mode. A SYN code 0001-0110 is attached to the beginning of a block made up of multiple characters. The block is then sent. In order to accurately send the data, two or more SYN codes are sent consecutively. Frame synchronization mode. A flag pattern of 0111-1110 is attached before and after a block made up of arbitrary bit strings. The block is then sent. It is also called the flag synchronization mode. Three. Transmission systems. When data is transmitted, there is the DC transmission system, where a DC signal that corresponds to the data code 0, 1 is sent as is baseband transmission. There is also the AC transmission system, bandwidth transmission, where the data code corresponds to an analog signal, or in other words, is converted into an AC signal to be sent. The DC transmission system is used for transmission over relatively short distances. It is for connections between computers and peripheral devices, and for networks within buildings. The AC transmission system is used for transmission over relatively long distances. It is used in phone networks. The operation of converting the data into AC signals, modulation, and the reverse operation, demodulation, are necessary. Using device called a modem which handles modulation-demodulation, data code is put on an AC signal called a carrier that has amplitude and a fixed frequency and transmitted. This is called a modulated signal. There are the following kinds of modulation techniques, and sometimes combine them for use. AM, amplitude modulation. When the digital signal is 0, there is no amplitude. When it is 1, there is amplitude. The illustration is a principle of modulation and demodulation of AM technique. FM, frequency modulation, changes the carrier frequency corresponding to 0 and 1. PM, phase modulation, changes the phase shift of the carrier. In phase modulation there are 2-phase, 4-phase, and 8-phase. The number of bits that can be expressed in each modulation are 1 bit, 2 bits and 3 bits, respectively. In addition, there is the amplitude phase modulation system with the combination of the amplitude modulation system and the phase modulation system is used. 4. Multiplexing systems. In order to effectively use the transmission line, multiple data signals are overlapped and transmitted. This is called multiplexing. There are 2 methods for multiplexing. One is frequency division multiplexing. The other is time division multiplexing. FDM, frequency division multiplexing. It is a system that has been widely adopted for analog transmission lines. Let us take an example of multiplexing 3 phone wires. 4 kHz is sufficient for the voice signal. Because of this, you can simultaneously send the carrier of 12 kHz on the first wire, 16 kHz on the second, and 20 kHz on the third. The receiving side can use a filter to separate the 3 kinds of signals. TDM, time division multiplexing. This is a multiplexing system with high affinity for digital transmission lines. The system divides a short, fixed period of time in order among multiple connected terminal devices. It then sends data in order over a single transmission line. There is a system that assigns the order in a fixed fashion. There is also a system that assigns the order as needed. 5. Analog transmission and digital transmission. In the beginning, when data transmissions were becoming popular, the phone network was used as a communication network, because it was already established. The data handled by computers is made up of digital signals of zeros and ones. Because of this, it is modulated into an analog signal for transmission. It is demodulated on the receiving side. This system is called the analog transmission system. Since 1965, the compatibility between computers has improved and digital technology has developed. Because of this, digital transmission lines that can carry digital signals have rapidly become more popular. The use of the digital transmission system has also increased. Digital transmission, when compared to analog transmission, has the following characteristics. High speed, large volume, and high quality transmissions are possible. 6. Transmission speed. The data signal speed and modulation speed are used as measures of transmission performance. A. Data signal speed. It means the number of bits that can be sent in 1 second, and it is often called data transfer speed. The unit is bits per second, bps, bs. B. Modulation speed. It means the number of cycles per second. The unit is the baud or baud rate. Seven. Communication modes. Communication systems are classified by the direction the data flows over the communications line. There are 3 types of communication nodes: simplex, half-duplex, and full duplex. A. Simplex mode. The sending side and the receiving side are fixed. Sending is always done in one direction. B. Half-duplex mode. Transmission is in both directions. However, transmission is limited to one direction at any time point. C. Full duplex mode. Simultaneous sending and receiving in both directions is possible. 8. Line connection methods. There are several basic connection methods for lines. Actual communication networks are built using a combination of these basic line connection methods. A. Point-to-point connection, direct connection. A dedicated line is connected between 2 points in this method. It is used when there is a lot of data. B. Multipoint connection, multidrop connection. A single communication line is shared in common with multiple terminals in this connection. This is more economical than the point-to-point connection when data volume is small. C. Switched connection. A switching device, or simply called switch, is used, and multiple terminals are connected in this method. The line is connected only when data is to be sent or received. Charges for usage of the communication line are based on time and data volume, so it is economical.